Hello everybody, today we're going to experiment with using Salesforce's Einstein image classification API to see if we can train it to recognize particular products. One of Salesforce's stated use cases is that Einstein can help marketers predict if they can spot the brands in social media images. I work in the life science space, so I thought a good exercise would be to see if Einstein can recognize particular packaging. The ultimate end goal would be to create a tool that helps reps count up the sample inventory by pointing their phones at the packaging and then signal a number, or have reps point the camera at the shelves of pharmacies and see if they need to replenish their signed products if their shelves are empty. So the first thing we need to do is actually create a data set. With all machine learning processes, we need some data set to start with. So what we can do is go to our friend Google, and you can search for images. So for example, if we use Havani, search for it, and these are all the images. I don't want to download these one by one, so the next thing I did is I searched the web for a tool to download these, and here's one handy Python tool. You kind of just run it, and then you'll download the images. So let's see how this works. Go to my editor, so you replace the search keyword, the keyword is blank right here, and go to the command prompt. So what we can do is Python Google images. So what the script's going to do is going to validate, and it's going to start downloading particular images. See, it's downloading right now, and then it's going to create a folder. So let's see what this folder looks like. Okay, so within the subfolder where your Python script is located, you can kind of see these are the images. So what I'm going to do here is put this into this view, and you can see the various different visualizations of this particular product, and this is going to be our data training set. Next thing you do is look at how Salesforce has set this up. So a good place to start would be the Einstein documentation at metamind.readme.io. First thing you do is set up your OAuth authorization, so you get a token that you can actually use. So in this case, the URL is going to be Einstein api.einstein.ai/token. So upload the private key you've generated earlier, then your account ID, and then I've set mine to expire in 60 minutes. So even if later on you take a look at this token, it's not going to be valid anymore. So after you have a data set, what I'm going to do is you're going to take this and we're going to upload it. So what I did is I took these three folders and I compressed it. So I called a zip file called top drugs. So let's say top drugs 2, and then I can upload it. So the upload mechanism you do right now via the terminal as well, and then you just have to upload a bunch of post commands, and it's very well documented within the Einstein pages. So for example here, I'm going to just upload the data set, paste this in. So in this case, pretty much to upload a local data set, you use this parameter data instead of path, and then now it's kind of doing the uploading. So after it's finished uploading, we're going to need to train the data set. So once this is finished uploading, and this is synchronous, so it may take a bit of time, we'll train it. And then afterwards, we'll get the status. I'll probably modify the Visualforce controller as well as the page to get us a page where we can actually experiment with its recognizing particular images. Okay, and I'll show you that page while this is loading. What you're looking at here is a simple Visualforce page that Salesforce provided as part of their Einstein sample code. So what it is that it's going to render the image that you provide and then give us the stats back from the classification engine. So in this case, it's 69% fine. What I'm going to do is modify the image. So I have a set of 4 images that I chose from the web. If we rotate it to the first image, Now refresh the page. So I rotated the front of the box. It actually has a 82% recognition rate of Havani. And then what I'll do now is rotate it to the back of the box. And the recognition actually has decreased quite a bit. It's actually misclassifying it to be embryo instead of Havani. It dropped down to 12%. This could mean a couple of things, which is that we need to actually train the engine and provide it more pictures of the back of the box. Alternatively, I think it may be a failure in my experiments because, to be honest, a lot of these prescription packages, they look the same. So if you look at this case here, right, so there's Humira, and then so we can find some picture of a box. Yep, I mean, they're just basically rectangular and it's got different color. And then if you have multiple brands that have the same color, I suspect that the classification engine's not going to pick it up that well. So the lesson learned really is that I think that image recognition is great, as you can see. It's automatically predicting what the picture is like, almost like a human. It probably needs more data points or more images to train it. But then for recognizing packaging in the pharmaceutical space, we probably need to switch to some other engine, such as a text recognition engine that's something like Google can provide, in which case it can read the word. Because the other thing that's going to be important is the form strength. Right, for this particular package, it's going to be 90 milligrams. And then the image classification is not going to pick up subtleties like that with words. So my next experiment is going to be going over and using a text image recognition API that can pull the text from images. Thanks for watching.